Have you ever thought about algae being used as a source for fuel? Chances are you probably haven't. It wasn't until recently that I learned algae could be used as a fuel. I have looked into some reliable scientific sources and am here to inform you of what algae biofuel is, what it could do for us, and how it could positively impact our ecosystem. For years, we as humans have contributed to the burning of fossil fuels, emitting tons of CO2 into the air, which ultimately has not been good for us, nor will it be in the future. Using algae as a biofuel has major positive features that could be key in curbing global warming. Allow me to first tell you a bit of background before explaining the benefits of its ability to become a fuel alternative and its hurdles. Over the past several decades, scientists have tested and researched the properties of algae and its use as a biofuel. I have become more interested in different fuel alternatives after learning about the effects of global warming. After researching different fuel alternatives, I began learning about algal biofuel. I then asked myself, how realistic is the possibility of regular gasoline being replaced by algal biofuels? I had never before thought that algae could have any potential to be a source of fuel. Some of its positive properties Some positive properties of algal biofuel include its ability to grow quickly, its ability to produce a lot of oil per cultivated area, and it absorbs a lot of CO2 from the atmosphere. One key leader in the research of algal biofuel is the company ExxonMobil. On ExxonMobil's website in 2018, they shared, "We believe our work with algae offers some of the greatest promises for next generation biofuels, which is why ExxonMobil has committed hundreds of millions of dollars in algae research. We are working with leading researchers and have designed our portfolio to progress the science that we feel is needed to deliver advanced biofuels with the environmental benefits." This here is what an algae biofuel farm looks like. ExxonMobil later shares that unlike ethanol and biodiesel, producing algae does not compete with the sources of food because algae can be produced in brackish water, including seawater. Its production will not strain freshwater resources the way ethanol does. Algae can yield more biofuel per acre than plant-based biofuels, currently about 1,500 gallons of fuel per acre per year. That's almost 5 times more fuel per acre than sugarcane or corn. Although it seems to have major positives, there are some hurdles that prevent algae from being mass-produced as a biofuel. Studies from the National Center of Biotechnology Information in 2010 share there are considerable challenges to making biofuels capable of competing with petroleum. Estimated cost of barrel algae-based fuel is using current technology is $300 to $2,600, compared with $40 to $80 for petroleum. Another article written by Let's Talk Science in 2020 shows that biorefining is a slow process. Algae grows fast, but extracting and refining the oil they produce is slow. It is slower than other methods of producing biofuels. Algal biofuel facilities are very expensive to build and operate. This means that algal biofuels may end up costing more than most people or businesses are willing to pay. It seems as though in general that there are great pros to the production of algal biofuel. However, there are also great cons. We would be able to benefit economically from the mass production of algal biofuel, yet in order to get there, it may cost more than what people are willing to pay. At first, I had a pretty good feeling that this is something that could be unveiled in the near future in order to help us with climate change or global warming. However, it seems that it will take time and lots of work in order to get this accomplished. ExxonMobil and many others are still committed to this project and are dedicated to this work. Using algae as a biofuel has many positive features that could be key in curbing global warming. For years, we as humans have contributed to the burning of fossil fuels, emitting tons of CO2 into the air. which ultimately has not been good for us, nor will it be in the future. In order for us to get there, it seems that we need to find ways to lower the production costs and make the extraction of oils more efficient. It seems to have great benefits and could be a great alternative in the future. My hope is for us to find ways to be able to bring this to market in an effective, affordable, and sustainable way. Thank you.